Hello everyone, it's Mrs. Burkhart here, and I am going to go over the Unit 6 review. So this video mirrors your Unit 6 tests, so you can try to work the problems out on your own first, or you can work out the problems with me throughout this video. So whatever works out for you, you can pause this video and work it out, or you can watch the entire video, and work out the problems with me. So whatever works for you, um, it's totally fine for me. And if you feel like you do have questions or clarifications on this Unit 6 review, make sure to reach out to me. Make sure to send out an email, and I will get back with you as soon as possible. All right, so let's get started here. So the first question is which graph depicts a normal distribution? So remember that a normal distribution of a graph, we know that the tallest frequency or the bar graph is in the middle, and it resembles a bell-shaped curve. So let's see here. It resembles a bell-shaped curve, and the rest of those graphs are tapered on the left and the right, and it's normally distributed. So looking at the graph, this is there's the total. There's the tallest bar graph here, which is in the middle, and it resembles a bell-shaped curve. So that would be a graph that shows a normal distribution. And remember, those taller graph in the middle, they are represented by a mu, or the mean of the graph. Now, the rest of the graph, this one right here, it's skewed to the right, and this one is skewed to the left, so that cannot be a normal distribution. All right, so the ones that we're looking at is shaped like a bell, so our answer for that is letter C. All right, for our second problem, we have here, suppose the length of an oarfish is normally distributed with a mean of 6 and a standard deviation of 1. What percent of oarfish have a length between 4 and 6 meters? Now, if you see here, I have a distribution of the um, normal distribution based on the empirical rule, and the middle and sorry, we have also here the percentage of the from the mean to the standard deviation above the mean, or the stand or 3 standard deviation below the mean. All right, so now we are going to use this normal distribution based on the empirical rule with the information given. So we have here a mean of 6. So this one right here in the middle should be our 6. Now, it is represented by a Greek mu. So that is represented by a mean and a standard deviation of 1. So if you have a standard deviation of 1 meter, so one standard deviation, we are just adding 1 from the mean 6, so that would be 7. So that's your one standard deviation. And your second standard deviation, you're adding 2 from the mean, so that would be 8. Okay, so that's your 2 standard deviation. And then you have adding 3 from the mean, so that would be 9. So that would be 3 standard deviation above your mean, and below the mean you're just subtracting 1 from the mean, so that would be 5, and subtracting 2 from the mean if it's 2 standard deviation, so that would be 4, and then this would be 3. Now we're looking for the percent of oarfish that is between 4 meters and 6 meters. Now if you're looking at our distribution, we're looking from this to this area. So this particular area from 4 to 6 centimeters. So that is our focus right there. Now, if you're looking at the percent, so from 4 to 6, it falls on 13.5%, okay, plus the 34%. So in total, that would be 48.5%. So that would be the percentage of that oarfish that falls between 4 to 6 centimeters in our normal distribution based on the empirical rule. All right, number 3. Given the masses of the oranges on sale at a farm stand are normal distributed with a mean of 239 grams and a standard deviation of 25 grams, what is the z-score of an orange that has a mass of 259 grams? So what we're going to do here is we are going to use the z-score formula. So given the information right here, our raw score is 259. So we are just going to use that formula. So z-score is equal to our raw score, which is 259. Okay, minus the mu, which is the mean. The mean here is 239. Okay, divided by the standard deviation, and our given information is 25. So then we're just gonna do our math here. All right, 259 minus 239, that is 20. Okay, divided by 25. You can use your calculator for this to find the decimal. So you can pull up your Desmos graphing tool. So you can, so I just went to the class, and then in your class homepage under class announcements, there's some link there. You can click on the Desmos graphing tool and you can just divide 20 divided by 25 on there. So use your keypad. 20 divided by 25, and then you see that answer right here, which is 0.8. So your z-score in this case would be 0.8. Okay, let's just move that. All right, that's number 3. All right, for number 4, given the heights of the peach trees in our orchard are normally distributed with a mean of 12.5 feet and a standard deviation of 1.8 feet. What is the height of a peach tree with a z-score of negative 0.5, rounded to the nearest tenth? So in this case, this is different from what is asking us from the other question, because this one, it is asking us for the raw score, for the raw height of a peach tree given a z-score. So in the other problem, we are looking for the z-score. So remember, the formula to find the z-score is z is equal to the raw score minus the mu divided by the sigma. So to find the raw score, what we do here is we can just multiply this by the sigma, okay, on both sides. So this ended up canceling each other. So we have z times the sigma is equal to x minus mu, and to find the raw score x, we're adding each by the mu. So then we ended up with the x, which we're looking for here, the raw height of a peach tree, is mu plus z times the sigma. So which is the same thing as this formula. So if you are familiar with converting the formulas to whatever you're looking for, you can actually look for what is asking in the problem by just familiarizing one formula. So you can use the z-score formula and then just convert it to whatever we are looking for in the problem. So in this case, you can use this formula or use the z-score formula to convert it to this formula, or just familiarize yourself with whatever formula you are comfortable with. So in this case, then we are going to use that raw score right here, that which is derived from the z-score, so which is this one is the same. So given that we have the z-score, okay, given that z-score is z negative 0.5, and we're looking for the raw height of the peach tree, which is the x is equal to the mean. Our mean here is 12.5. Okay, plus the z-score, which is negative 0.5, okay, times the standard deviation of 1.8. Okay, so then we can just do the math here. So let's just move here over here. So 12.5 plus, so we're going to use our decimals, so negative 0.5. So negative 0.5, negative 0.5 times, 1.8. 1.8, we get negative 0.9. So negative 0.9. So 12.5 plus negative 0.5. So 12.5 plus, or just minus 0.9, you'll get 11.6. So that would be the height of our peach tree, 11.6. And now it is already in the 10th place, because remember, one decimal place is also the 10th place. All right, so that would be number 4. All right, question number 5. We are given 4 bowlers and having the z-score listed below for their bowling scores last week. And then based on the z-scores, we are asked which bowler had the highest score last week. Now, if you notice, we are not given any information about their raw scores or even their mean or the standard deviation in the problem. So there's no way we can change the z-scores into its raw scores. But if we understand what a z-score is, we can actually use the normal distribution, which is shown below, to figure out the answer to this question of who or what bowler or which bowler had the highest score last week. Now remember, the z-score just describes how many standard deviations a data point is from its mean. So we have here a normal distribution, and if 0 right here, 0 score is the mean. So if we're looking at Michael's z-score, negative 2.5, and if it's a negative, we know that it is below the mean, and it's like 2.5 below the standard deviation below the mean. So that means if this is 0 score, which is the mean, so negative is below the mean, so it has to be on the left side of your curve, and it's 2.5 standard deviation below the mean. So we are gonna put, so if this is negative 2 right here, 2 standard below the mean, so Michael's z-score is about here. So let's put M there for Michael. And then Jimmy's score is negative 0.5. Now, if this is 1 standard deviation below the mean, so z-score of negative 1 is 1 standard below the mean, so that means Jimmy's score is just halfway, okay, below the mean. So that means below halfway is around here. Okay, that's negative 0.5. So that's where Jamie scored last week. And then Maya z-score is 2, positive 2. And if it's a positive 2, okay, that is 2 standard deviation above the mean. So if this is the mean right here, which is a 0 score, so 2 standard deviation is right here. So that's Maya's score. So Maya, let's just put MY. And then Rachel's score is 0, meaning it's just the average, okay? So it's just right on the average. So that means if the mean right here is the average and Rachel's scores z-score is 0, so Rachel's bowling score is just right average, and Maya is above average, and then Jimmy is just halfway below the average, and then Michael is right there, okay, which is 2 standard deviation below the mean. So if we're looking at the highest score, so obviously, so this would be right here would be highest, okay? And below the mean would be the lowest. So if you look at here in our arrangement, it looks like Maya right here has the highest score because she scored 2 standard deviation above the mean. So above the mean right here is the average. So it's just um, Maya is above the average on the normal distribution. So we have there as Maya scored the highest last week based on their Z scores. And if you're looking at the lowest score, so obviously Michael scored the lowest because he's all the way below the average or below the mean. All right. So that's for number 5. All right, for number 6, we are given the amount of caffeine in a single serving of tea is normally distributed. For a particular comparison, single servings of 2 different salient tea mixtures are compared. So mixture A here has a mean of 50 milligrams and a standard deviation of 3.3 milligrams. Mixture B, on the other hand, has a mean of 52 and a standard deviation of 2.3. Suppose you are given a serving of Ceylon tea that contains 55 milligrams of caffeine. Which mixture is the tea more likely to come from? So what we're going to do here is we are going to compare their Z scores. So remember your Z score formula. Okay, let's put my thing here so you can see your Z score formula. So you have this Z is equal to the raw score minus the mean divided by the standard deviation. So we are going to find the Z scores for each mixtures, and then we are going to compare them. So mixture A, what's going on here? Sorry. There you go. So we are going to first find the Z score for mixture A. So mixture A, okay, has a mean of 50 and a standard deviation of 3.3. So our Z score right here is always 55, okay? Or sorry, raw score is 55 minus the mean for the mixture A of 50, okay, divided by 3.3. So let's use our Desmos calculator right here. So 55 minus 50, that makes it a 5. So 5 divided by 3.3. Okay, so we have your 1.5, 1.51 or 1.52. So this is 1.52. Now we are going to find the Z score for mixture B. So the Z score for mixture B, so we still have the raw score, which is 55, minus the mean of the mixture B, which is 52, divided by the standard deviation of 2.3. Okay, so 55 minus 52, that's 3, and then divided by 2.3. So let's go ahead and divide that. 3 divided by 2.3. So we have about 1.30. So we have here 1.30. Now to answer the question, which mixture is the tea more likely to come from? Now when we are comparing two things and we are answering the question more likely, we are looking for a Z score closer to 0. Okay, so if you are looking at these answers, okay, 1.52 and 1.30, so which one is closer to 0? So 1.330 is closer to 0. So that means it's more on the T. The T is more likely to come from likely to come from mixture A. Oh, sorry, from mixture B. All right, so again, when you are comparing for where is a certain item or certain thing is more likely to come from, we are going to look for a z-score closer to 0. And in this case, it's mixture B. All right, so for number 7, okay, given that company A produces packages of hazelnuts that are normally distributed with a mean of 92 and a standard deviation of 2.5, and then company B produces packages of hazelnuts that are normally distributed with a mean of 95 and a standard of the standard deviation of 1.5. So which company is more likely to produce a package that has 90 hazelnuts? Now, again, we are comparing two companies right here, of which a package is more likely to produce 90 hazelnuts. Okay, so again, we are looking for the z-scores, and we are looking to compare the z-scores as closer to 0. So company A, okay, so we are looking for the z-score for company A. The raw score right here is 90 minus the mean for the company A, which is 92, divided by 2.5. So in this case, 90 minus 92, that's negative 2. So negative 2 divided by 2.5, negative 2 divided by 2.5, you'll get negative 0.8 for that. And then company B, you have the z-score of, so raw score here is 90 minus, so company B has a mean of 95, okay, minus or divided by the standard deviation of 1.5. So 90 minus 95, that's negative 5 divided by 1.5. So negative 5 divided by 1.5, we get negative 3.3 repeating. Oops, sorry. So negative 3.3 repeating. Now looking at the z-scores, so which is closer to 0? Because again, we are asked about that word more likely to produce, so we're looking for closer to 0 or closer to the mean. So in this case, it would be negative 0.8 is closer to 0. So company A is more likely to produce a package that has 90 hazelnuts. Okay, so we are going to answer that. All right, so that would be our answer for number 7. All right, so for number 8, use the z-score table to answer the question. The expression p z less than negative 1.23. Now the p right here represents the probability when the z-score is less than 1.23, represents the area under the standard normal curve below the given value of z. What is the probability when the z-score is less than negative 1.23? So we are looking for the area represented of the z-score that is less than 1.23. Now remember, if this is your normal curve and this is your mean z-score of 0, so negative means that's below the mean. So if this is one standard, okay, sorry, let's put this as, if this is negative 1, one standard below the mean, so negative, and this is negative 2, so 1.23 is somewhere in this area right here. And then we are looking for the probability, the area that represented under that normal curve. And using this score z-score table, we can actually answer the question. So I did link, okay, the z-score table here under If you click your Algebra 2 class and under class home and under class announcements, so if you pull up the z-score table, standard normal table, that .pdf, okay, it will show you the table of the z-scores. So using this table, we can actually look at the area that represented on those z-scores. So I'm gonna, all right. So how are we gonna use this table is first we are looking at the first whole number here, which is -1, and the first decimal place, which is 2. So -1.2 on the first column of your table. So -1.2, that's what we're looking at your z-scores right here in the first column. So -1.2 is right here. So -1.2. And then on the rows, on the first row would be the second. Let's just put this one over here. And then this one right here, the 3, which is the second decimal place or the hundredths place, is what we're looking at the first row of your table. So the first row, so given that this is your whole number with the tenths place of your decimal, and your hundredths place or your second decimal place would be 0.3. So that's what we're looking at the first row of your z-score, so 0.3. And then we're gonna just line them up. Okay, line them up, and whatever number that they intersect between -1.2 and 0.3, so that would be your probability. So it would be 0.1093, so, because that's where they meet actually. So -1.2 and 0.3 meets at that number, so that would be your answer. It would be 0.1093. So P, or probability, or the area under that standard normal curve where z-score is less than -1.23, is equal to 0.1093. 1093. All right, for number 9, using a z-score table to solve, at an amusement park, a roller coaster has a minimum height requirement of 44 inches. Given that 6-year-old girl heights are normally distributed with a mean of 45.2 inches and a standard deviation of 2.1, what percent of 6-year-old girls will not be eligible to ride because they did not meet the minimum height requirement? And we are asked to round to the nearest whole percent. So in this case, in order to use our z-score table, okay, our z-score table, we need to find the z-score of this raw score 44 inches. So we have to find, or we have to convert that raw score into a z-score first before we can use our z-score table. So to find that z-score of that raw, okay, height of a raw height of a certain minimum height requirement of that roller coaster ride, we need to find the z-score first. So 44 is a raw score, and subtract it to the mean, which is 45.2, okay, divided by the standard deviation of 2.1. All right, so then we have 44 minus 45.2, so that's actually -1.2, okay, and divide that by 2.1. So using my calculator right here, I take -1.2 divided by 2.1. I get this answer, so I'm just gonna round it to the nearest tenths, which is -0.57. So the z-score right here would be negative 0.57. So again, if this is your normal distribution, so I know that is below the mean. So if this is your mean right here, which is 0 z-score, and if this is your 1 standard deviation, which is z-score of 1, negative 1, so your z-score negative 0.57 is right here. So negative is just past halfway, so negative 0.57. So we know that is below the mean, and we are looking for the percentage. So that means going to your table, so we are looking for negative 0.57. So your whole number here is 0. So you're just looking at the first decimal or the 10th place, which is 0.50 on the left side of your table or the first column. So z under z negative 0.5 is right here. Okay, so, and then looking at the hundredths place or the second decimal place, which is 7. So what we're looking here is 0.07 on the first row right here, so 0.07. So we're just gonna see what number do they meet on negative 0.5 and 0.07. So it looks like it's this one right here, so that's where they meet at 0.2843. So 0.2843. So that would be 0.2843. Now, that's not the percent because that's the area. So changing this to a percent, we have to multiply that by 100. So multiplying that by 100, you'll get your percent, which is 28.43. And to round it to the nearest whole percent, we're looking at the number next door from 8, because if we look at here, the number next door is 4, and that means if it's 5 and up, you round up your 8 to 9, but however, this is below 5, so that means we have to keep it as 28%. So that would be your percentage of girls that would not meet the minimum height requirement for the roller coaster ride. So there's going to be 28% of the 6-year-old girls. All right, so there you have it for number 9. All right, for number 10, the number 0.9463 represents or under the standard normal curve below a particular z-score. What is this z-score? Write your answer as a decimal to the nearest hundreds. Now, I know that this one right here, the z-score would be a positive z-score, because if you're looking at the standard normal curve, all right, so if this is your mean, and if this is below 50%, so that would be negative. And we're looking at 94%. If you're looking at 94%, so that would be above your z-score. So that would be 94%, so above the 50%. So it should be around here, which is above your 50%, so above your mean. So that means your z-score right here are positive. So in this case, in order to calculate the z-score, so we need to actually use the z-score table, and this time we are looking at the body of your table, and we're looking for this number right here. So your body, so it looks like we are looking for a positive z-score, and we're looking for 0.9463 in the body of your z-score table. So 0.9463. So I'm seeing here we are 0.912, so we are supposed to be 0.9463. So we are 0.952 here. So it's right here, 0.9463 is what we're looking for. So now we are going straight across from that number. So if you're looking at straight across from the numbers on the first column of the z-score, we have 1.6. So the z-score for that is 1.6, but then we are looking at the nearest hundreds. So then we are going to line up straight up here, and what would be the number all the way up? So it would be 0.01. So we are just adding that one here. So 1.6 plus 0. 0.1. Okay, so yep, 0.0.01. If you're adding that, you'll get a 1.61. So that would be your z-score for that number. All right, for our last question, we are using a z distribution table to find the indicated area. The scores on a standardized exam are normally distributed with a mean of 400 and a standard deviation of 50. Approximately 60% of the scores are less than which score. So if I'm going to visualize this on a graph, so if I have my normal distribution here, oops, my thing is not working, so let me turn on the pin. So if I have my normal distribution here, and this is my average mean, so this is my mean right here, so that's 50%. So 60%, so the area 0.6, it has to be somewhere here, so it's just above the mean. So this area right here, which is 0.6. So in order to find the raw score, okay, of what scores that falls under that area, we need to figure out the z-score first. So going back to our table, we wanted to know the area in the body of a z-score that is 60% or 0.60. Now in this case, there's two numbers that is close to 60% or close to 0.60. We have the 0.5987 and the 0.06026. Now whatever we're going to use, we have to figure out what is the slightest difference, or what is closest to the difference is closest to 0.60. Okay, so if we are going to take 0.6, so let's go ahead and take 0.6 minus this one right here, 0.5987, 0.5987, what would that be? And then, so let's go ahead and subtract that. 0.6 minus 0.6 minus 0.5987. Okay, so it looks like we have 0.0013, 0.0013, and then we have the other one, which is close to 0.6, this one right here, 0.6026. 0.6026 minus 0.6, then you have 0.0026. Now if you look at here, closest to 0.6 is this one right here, because it's we have the slightest difference. Okay, there's only 0.0013 difference. So we are going to use this area right here to find the z-score. So we're going to use this area. So the z-score would be 0.25. So let's look at here. So the z-score would be 0.25. Now to get the z-score again, the 0.2 right here is coming from the first column of your z-score if you're just lining up, and then the second decimal place is lining up straight right here. That's where we got the hundredths place of the decimal, which is 0.25. Okay, So now we can use that z-score to find the raw score. So the raw score right here, given that the mean is 400, okay, plus the z-score of 0.25 times the standard deviation of 50. So using the math here, we have 400 plus 0.25 times 0.25 times 50, okay, times 50, so you have 12.5. So 12.5, adding them up, you have 412.5. So that's our raw score right here. So 412.5. And if our mean is 400, so your mean right here is this one right here, and it's just above the average, which is because the mean right here is 50%, and above the average would be 60%, is just above 50%. So it makes sense with our answer. So the score, the raw score that falls in the range of 60% on your normal distribution would be 412.5 scores on the standardized exam. All right, so if you do have questions on this review, please let me know. All right, have a good one. Bye.